In this video, I'm going to explain about the basic concepts on linkers, loaders, and their importance. Okay. So now in this, I'm going to cover these are the things. So first, I will explain what you mean by the compilers, interpreters, assemblers, and what are the importance of this, what these will do, and then object files, executable files. Finally, we will come to the our main topic, linker and loaders. Okay, suppose if you are good in these things, you can directly go to these topics. Okay, so let us see one by one. So we know that we users, whatever the files, whether it may be the software or it may be the anything, so you always store in the secondary memory, right? So everything, every file we are storing in the secondary memory. That means we user, so we have secondary memory. That is the secondary memory. So user will store everything in the what? Secondary memory. So now the user store all in terms of programs, and these programs are generally written in the form of high level language. Okay, whatever the user programs we are writing, that means whatever the program we write, so that is in the higher level language. That means we use either C or C++, Java, Python, .NET, like that. We are using some high level languages, and using that we are writing the programs. But whether these programs are going to understandable by our CPU or the machine, no, because our CPU knows only what? 0 and 1. Only these two values our CPU can understand. Other than 0 and 1, our CPU doesn't know anything. So that means, so whatever the processor understood, so we need to write the from 0 and 1. That is what machine level language. That means our CPU knows only machine level language, but we have written what? The program in high level language. So here comes our CPU. CPU is here. So our CPU is responsible for performing all the tasks, and it knows only machine level language, but we have written the program in the form of high level language. Okay, so it knows only machine level language, and we have written this program in high level language. Okay, now, so CPU cannot execute this one because it doesn't know high level language. So what we have to do, somebody should translate the program written in high level language into this machine level language. Then it will give that machine level language. If we give it, it can execute easily. So again, to convert the program written in high level language into the machine level language, again we are using one system software, and that system softwares are nothing but compilers and interpreters. Both, okay, these both are used to convert program written in high level language into machine level language. Okay, so then what is the difference between these two then? See, our compilers are the system software which are converting program written in high level language into machine level language by checking the entire program once. So it scans, okay, two pass assembler will call. So that means it will check our program line by line, everything, and at once it will give all the things. That means it will show all the errors, or it will convert the entire program once if it doesn't have any error. So it will convert the entire program into high level program into machine level language. That is what compiler. Whereas interpreter is same as compiler. That means interpreter is also a system software which converts program written in high level language into machine level language. But instead of compiling the everything, so it will convert line by line. It takes the first line and converts into machine language, and then takes the second line, converts. So that is what interpreter. So your Python is interpreter language. Okay, whereas the C, C++, Java all are compiler program. Okay, so now we know what you mean by compiler, interpreter. Both are system software used to convert programs written in high level language into machine level language, but only difference is it will do line by line, it will do at a programs once. That's the only thing. Next, see, we are using different type of computer systems. Okay, if you take Intel computer processor only, we have right now we have i3, i5, i7, i9, i11, like that. We have different versions. Every processor has its own instruction set. That means every processor can understand only set of instructions. Like what if people studied in computer organization, like load something, you must store, move, add, mul. So these are some of the instructions. So every processor has its own instructions. Okay. So whatever the high level language, so first we need to convert into machine level, assembly level language. Okay, then that assembly level language into the machine level language, because that processor is having some set of instruction. First high level language instruction we have to convert into assembly level instructions, then assembly level language instruction to what? Machine level. So again, assemblers are the what? Assemblers are also the system software which will convert program written in assembly level language into what? Machine level language. So first our compiler will convert into a high level language to machine level language, and assembler, that means whatever you suppose if the program written is assembly level language, that will be converted into machine level language. That is a task done by the assemblers. Okay. So now we'll see that is what do you mean by this object files. So these three are used to translate our program from one language to machine level language. So we call these three as translators. Okay, translator. That means generally user has written the program that we will call as a source program. This source program may be anything. It may be written in what? High level language or assembly level language, and that we need to convert into what? Program. So in machine level language. So our source program is get translated into machine language. For that we need what? Some translators. Okay. In general we call translators. So these translators are nothing but any one of these things. Okay. So now whenever our program is converted into machine level language, that we will call it as a source program. And once it converted into machine level language, and that we will call it as what? Object file. And this object file is what? It is in the form of machine level language. Okay. But this object file, once it is converted into machine level language, what I said, or CPU can execute. But once object file is created, or CPU still cannot execute because it is not ready to execute file. Okay. So again I am repeating, whenever our source program is converted into machine level language, right, that program we call it as an object file. Even though this object file is in the machine level language, that is 0 and 1s, but still it is not ready to execute. Why? I will tell you. Okay. See, we are using so many programming languages. Okay, whichever the programming language, in every program we are giving some input and it is doing some operation and then produces some output. So in order to print the output, we have to, that means you have to print the output or to accept the inputs. So we have to use some standard input-output functions. That is library IO functions we have to use. Like in Java, we are using system.out.println. In Python, we use print. In C, we use printf. Like that. So these are similarly, we use scanf. Okay, or read. Okay, or scan we will use. That means these are the inbuilt IO functions. Okay, but here we say just printf. Just system.out.println. But we are telling just a print. But how to print that that is explained in some other file. Okay, let us take in C. The very first time what in C is #include stdio.h, #include conio.h. Like that, at the beginning of the program, we are including many header files, and then we start our executable program. Okay, so that means, assume similarly we are using many mathematical functions also in our program. So we may use a ceil mathematical function to round it off to the higher. Okay, that means to round off to the upper. And similarly to round it off to the lower, we are using floor. Similarly, whenever we want to find out the square root of a number, we are using sqrt. Okay, sqrt. Whenever you want to find out the power of, we are using pow. And whenever we want to find exponential of something, we are using exp. Like that, we are using so many mathematical functions in our program. But how that mathematical functions find that value, that is defined in some other files. Okay, assume. Now, the summary is, in every program we are using some functions or also subroutines or classes or methods we are using. Okay, and Functions means it may be the library functions or the inbuilt functions, or it may be the user defined functions, and these are defined in some other files. Okay, suppose assume this is my main program. Okay, assume this is my one main program, and in my main program some statement is there. After that I may use, say for example, some scanf statement I use. This is one standard input function. Okay, formatted input function. Then after that assume I use some find out sqrt mathematical function I use, and then assume after some time I am using some printf function. Assume this is main code. Okay, now whenever we execute this, the content, this one, see for scanf it create what? One object file. So I will call this as an object file 1. Similarly, for sqrt, it generates what? One more object file. So now we'll call this object 2. Similarly, for printf, again one more, that is I'll call object file 3. Object file 3. Now, then remaining these statements, again one more program, that is what? That is for the main. So that we will call as an object file 4. So that means for every program, how many number of inbuilt functions or mathematical functions or user-defined functions are used, that many object files should be created. Because see, how to find square root, it is defined in another. So that also get converted, right? That is also done in high level language. That also should be converted into machine level language. So for that is for each and every function or subroutine or classes or methods, we should have one separate object files. So that means one program, what we return, so that will be made as many object files. All these are machine level language. Now, because if you run any one, so we are not getting our complete task output, because you need to combine all these things. Now, all these object files should be combined together into one single large file, and that we call it as executable file. Okay, so now that all these individual object files should be connected together to make one single large executable file, and again this is also in machine level, because this is machine level language, these are we combined into one, so this is executable file. So okay, that means now this exe file is, that was exe file we call. Okay, this file is ready to execute. That's it. It is able to execute. That's what ready to execute file. But still, this exe file, when we convert our high level language into exe file, this file also in what? Secondary memory. This corresponding what? Corresponding exe file also is in what? Secondary memory. But we know that whichever the program we want to execute, that should be in the what? Main memory. So we need to bring that executable file into the main memory. Now this is your exe file. Okay. Now once we bring that exe file from secondary memory to the main memory, then our CPU can take this instruction by instruction and can execute. So this is ready to execute. Okay, now I told see, for converting our high level language program into these individual object files, for this will be done by whom? Translators. That means compilers and assemblers. So here we need compilers or assemblers we need. Then after that, after linking this, so in order to convert the moment, or in order to connect, in order to link these individual object files, we need what? Here linkers we need. That's what the linkers. Now again, linker is the system software which is used to link individual object files generated by the compilers or assemblers into a single executable file. Okay, so that is the task of the linker. Once exe file is generated, and that should be moved to the main memory by your what? By loader. So now loader is again a system software which will moves or which will loads the exe file which is ready to execute. So that exe file will be moved from secondary memory into the main memory by loader. Okay, so all these are the system programs, and all these are part of an operating system. So our operating system should contain all these systems of system softwares. Now hope you people understood what all these things are, right? These are the translators, so which converts program written in high level language or assembly level language into machine level language. So then once it will generate the machine level language, that will call as an object files. For every program we have multiple object files, because so that how many number of object files, that depends upon how many number of functions or subroutines or classes methods we use in our program. Okay, so all these individual objects should be linked together into a single executable file. That will be done by our linker. Once exe file will be generated, that is still in the secondary memory, that has to be brought into the main memory, and that will be done by the loader. Okay, now this is the thing. Now what I said, that exe file has to brought into the main memory by the loader. But we know that our main memory contains so many blocks. Okay, for 8 GB means 8 followed by 9 zeros, that many number of blocks are there. Now the question is, where exactly loader will brings that one? In which address? So that address is generated by whom? So now that address is generated. Earlier address is generated by the programmer only, or before 1975. At that time, the programmer while writing only has to generate the address, saying that address you should that exe file should be stored in so and so address in the main memory. So that means user is having that burden. That means you should know the main memory status. But later on, assembler only is giving the information that where the so and so instructions or the program should be loaded into the main memory. So that's what you people studied in computer organization, say addressing modes, relative addressing modes, indirect addressing modes, direct addressing modes, base with index addressing mode. So like that you people studied different types of addressing modes. So that's what. So they say, so which should be stored in which. So assemblers are giving the address. Assemblers are giving the address. Okay. So we're generating the object files. Then it will say this object file should be loaded here. This object file should be loaded here. Like that, assemblers only gives. So that means now how it will came to know. So again, see, all assemblers are the part of the loader. So this loader will communicate with the main memory management, and then memory management is going to maintain a table called free frame table. So in that it will maintain which are the frames are free in the main memory, which are the frames are already allocated to some other processes. It will maintain the table. With the table, it will give information to the loader, saying that which are the frames are free. So based on that, loader will decide where to move the executable file from the secondary memory to the loader, to the main memory. So now, major tasks performed by the what? Loader are first thing is should do allocation. See, first thing, whenever we double click on that, when on any file, first you should get translate. After translating, so then you should allocation. Loader should allocate. That means in which address it should get allocated. So then once translated, our object files will be created. So that object files should be linked together. So linking should be done in order to create the executable file. Once linking is done, sometimes what happens, whatever the address specified by the loader at the first stage, it is not possible, because sometimes it may be overwritten by some other files, object files. At that time, now it has to relocate to some other addresses. Okay, so that means now suppose that particular memory location is busy or not free. So at that time, it has to relocate this object file to some other address in the main memory, in which main memory allocation, main memory free. Okay, at that place it has to relocate. So third is relocation. Okay, then finally, the exe file, that is executable file stored in the secondary memory, should be loaded into the main memory, address specified by the allocation or reallocation. So the fourth step should be the loading. Okay, so loading into the main memory. Once it is loaded into the main memory, then CPU can take the instructions one by one and executes. Okay, so these are the major tasks performed by any type of loader. Okay, in my next video, I'm going to explain what are the different types of loaders. Okay, so now hope you people have understood the concept. If you have any questions, please write it in the comments. Thank you. Thanks for watching.